Greetings everyone. Welcome to Conf42 Machine Learning 2025 conference sessions. I am Srinivasan Pakkirisamy, Director of Technology Portfolio at SPL Consulting Inc. with over 23 years of experience in IT, specialized in enterprise cloud architecture, multi-cloud integrations, data management. I also have specialization in financial systems, Oracle Cloud ERP, and payment processing. Do you know that over 67% of multi-cloud integration projects implementation overrun because of the challenges in the data and the complexities in the integrations? So today's sessions, we will cover mastering multi-cloud ERP integration, a framework for data normalization and synchronization. So ERP implementations and the systems evolved over the period of time from monolithic architecture to highly distributed cloud native implementations. So organizations are adapted to implement multiple clouds based on the domain specialization rather than implementing a single ERP or single cloud ERP. So example, if you take financials, Oracle Cloud ERP is best in the market, whereas Workday is for the human capital management, Salesforce for customer relationship management, and Bully Under for supply chain optimization. So if the enterprise want to use best of the domain cloud ERP system, then implementing these multi-cloud in the enterprise ecosystem is inevitable. So the strategic approach delivers a superior domain-specific functionality for the enterprises and the business. However, it also brings a lot of challenges and divergent data models, inconsistent APIs, and varying issues across the board. Let us look at this multi-cloud ERP ecosystem. Oracle Cloud ERP, specialized in financial domain, is implemented by almost 41% of the Fortune 500 companies. So it has various modules. Example, general ledger, account receivable, account payables, fixed assets. And it also has superior functionalities of financial consolidations and reporting functionalities. Workday is a human capital management specialized ERP, and it has unified data architecture for the complete workforce operations for any enterprises. It holds over 38% of market share across the enterprises with over 10,000 employees. However, Workday is using SOAP-based web services with the complex XML schemas for their data needs. Salesforce is customer relationship management ERP system. Almost 56% of the multi-cloud ERP ecosystem holds Salesforce for its CRM needs. The Salesforce ecosystem uses event-driven architecture, generating almost 12.4 million event notifications daily in large-scale implementations. Bully Under, on the other hand, is specialized in supply chain orchestration with over 28% of market penetration among global enterprises. If you look at all these ERP systems, they are superior in functionality in their respective domain and almost have a very good market share across the Fortune 500 and other enterprises with the large scale operations. So the enterprises adopted these different ERP systems to support their functionalities and the domain needs, which gives the complexity. The very first challenge which we are going to look at multi-cloud ERP implementation is schema heterogeneity challenges. We looked at why enterprises are adopting to implement multiple cloud ERP to gain the superior functionalities available in each domain. However, the fundamental challenge in multiple cloud ERP integration lies in reconciling their divergent data models. Each cloud ERP provider they design their data model with different architectural philosophies to support and gain the superior functionality in each of the domain. Though this gives very good architecture and data model for individual cloud ERP, integrating these data models across the cloud ERP is always complex and provides challenges. The substantial barrier is to integrate or exchange this data which has different schema or properties. If you look at it, the Oracle Cloud ERP, which holds the financial data, has complex chart of account segments, lot of business rules. However, these chart of accounts and business rules are exchanged with other cloud ERP to derive the accounting information. Similarly, the Workday, which holds the employee data, has 23 related objects with over 200 plus attributes per record. When this is exchanged with other cloud ERP in the ecosystem, they do not need all these attributes. However, the exchange substantially become complex to get any user related information from Workday. The Blue Yonder system, which holds the product information, there are a lot of master repositories, and syncing them with other cloud ERP bringing a lot of latency. The CRM, which holds the partner data, it has a lot of fragmented attributes, which also brings the complexity across the cloud ERPs. So this schema heterogeneity always provides some challenges which needs to be solved. Semantic mapping complexities. Beyond the structural differences which we saw, the semantic variations compound normalization challenges in multi-cloud ERP ecosystems. Even when the systems appear to represent similar business concepts, subtle differences in terminology, hierarchies, and business rules create significant integration obstacles. Let us look at this example of how the business partner represented across multiple cloud ERP systems. The supplier representation in Oracle, whereas in Oracle Cloud ERP, the financial relationship, payment terms, and tax information and accounting classification of the suppliers are maintained, where the enterprise do business with any purchasing relationship is called supplier. However, the same supplier is represented as account in Salesforce, whereas the primary attributes around these accounts are related to relationship attributes, how we communicate with them, what is the cases with them, what is their histories, and what are the opportunities we have with them. It's completely different than what it is being represented in Oracle. The same supplier which is mentioned in Oracle, now if you look at the Blue Yonder, it's called vendor, whereas the primary focus or the attributes for the Blue Yonder system is the logistic performance metrics, delivery capabilities, and supply chain reliability. So this semantic reconciliation, almost 43% of development effort is spent on this. We have seen schema heterogeneity challenges and semantic mapping complexities. However, organizations have developed several sophisticated technical mechanisms to address these challenges. These challenges or approaches vary in complexity and architectural impact, with the selection typically based on specific integration requirements and technical constraints, also based on the organization's capabilities. There are three predominant options available for us to handle these challenges. The first and widely used option across the enterprises are ETL. So you extract the data from the source cloud ERP, transform it to the target, and finally load the transformed or mapped data into the target cloud ERP. So this ETL option is widely used and very simple in terms of the implementation. However, most of the work or mapping are being done in the transform layer. The second option which we have is schema mapping engines. So you have sophisticated engine which take care of all your heterogeneous schema mappings and across different systems, cloud ERP systems. It reduces the development effort because the engine provides the mapping for various cloud ERPs, which can be adapted by different integrations and seamlessly will work. The canonical data models are evolving as a trend and standardization to normalize these complexities, whereas each source ERP system, the cloud ERP system, which is master in their data, agree with other cloud ERP systems across the enterprise to standardize the format or the canonical data model and publish them as a publisher subscriber model, so that the consumer will have standardized data and attributes available in the form of the canonical data model to them. So this takes a lot of initial design complexity. However, in the long run, it reduces the overall the mapping or the implementations required by the consumers in the later part. Latency and consistency challenges. In the distributed multi-cloud ERP system, various data elements are shared across ERP systems. Thus bring a significant timing challenges that can compromise the business process integrity. If you look at it, approximately 68% of the organizations report their business impact from timing related data discrepancies across integrated cloud platforms. These delays can occur due to various reasons. Example, there is a network latency or large processing queues between one cloud ERP to other cloud ERP, or there are validation rules which the data will not go through to the target cloud ERP. Sometimes there are middleware transformation overhead. All of these causes two things. One is either there is a latency, sometimes there is a integrity challenges. So if you look at it, transaction propagation delays, there are almost 8 to 15 seconds for the standard transactions, up to few minutes for the complex ones across the cloud ERP systems. The eventual consistency models, there are 47% of the data entries operate under eventual consistency. The event-based triggers are very complex. It brings overhead to the cloud ERP data model. High volume data streaming also contributes to these latency and consistency challenges. With latency and data integrity challenges, there needs a conflict resolution strategy. So in the multi-cloud ERP, there are a lot of bidirectional data flows between the cloud ERP systems. First, we have to detect the conflict on time and also need to provide a proper resolutions to handle this integrity and the data conflict resolution. The research indicates that approximately 6 to 8% records in the bidirectional synchronization scenarios experience these update conflicts. This percentage may increase up to 12 to 15% if the data is getting modified frequently across the multi-cloud ERP systems. So there are certain strategies available for us to resolve this conflict. The widely used approach or strategy is time-based resolution. What it means is always giving the precedence to the most recent update. If there is a conflict between multiple updates, ignore the one which we received earlier, go with the latest or recent update. So this is called timestamp based approach. The second one which we have is domain specific rules. Say example, when there are conflict arise between the data element, the domain specific rule or the data element wins that conflict and it takes the priority over the other element. Say example, if accounting, financial system, Oracle Cloud ERP is the master, or the supplier if Blue Yonder is the master, or the customer if Salesforce is the master, the domain specific system takes the precedence over the other systems and holds that attribute or the data integrity. So that is the domain specific conflict resolution approach. The next one is manual reconciliation. Say example, you cannot use time based or we cannot use domain specific rule. However, it needs a manual intervention to reconcile the data to understand which takes precedence and apply it. There is still a 15% adoption to this strategy. The last one, which is conflict-free replicated data types, is the industry standard which we want to go to. It's 8% adoption. The way it is implemented will avoid the conflict and it will be conflict-free replicated data type. Framework for synchronization. An effective synchronization framework for the multi-cloud ERP system must incorporate several architectural components that collectively address complex requirements for data consistency and resilience. Organizations implementing comprehensive frameworks experience approximately 76% fewer data consistency incidents compared to those relying on point-to-point integrations. If you look at this different architecture framework, the Oracle has a BCC connector which simplifies the extraction. Thus, it reduces the extraction complexity by 45%. If you look at the Salesforce, which has the change data capture, it reduces almost 97% in the data volume compared to full synchronization. The event streaming backbone for Blue Yonder, which publishes the data or stream the data into Kafka, also almost process 50,000 to 100K messages per second. The smart batching strategies, which improves almost 120% with the adaptive approaches. Adopting a right framework and strategy between the multiple cloud ERP based on their capabilities will improve the data synchronization and reduce the data inconsistency issues. While we are doing data normalization approaches and solution for heterogeneous schema challenges and semantic mapping complexities, and also synchronization framework to address data inconsistency and latency issues, one should not overlook the security issues the multi-cloud ERP system brings in. Compared to the single cloud deployment or the on-premise deployments which are more protected, the exchange of data between the multi-cloud ERP system, especially the sensitive data, brings more vulnerability. So approximately 41% of more security incidents related to the data exchange in the multi-cloud ERP system compared to the single cloud ERP systems. So we need to have some security consideration. Those are like, say, cross-platform authentication. So how do we authenticate between multiple cloud ERP systems? The widely used authentication mechanism OAuth 2.0, which is almost 82% enterprises adopted these kind of approaches to secure their multiple cloud ERP systems and its data. However, there are 72% of multi-cloud ERP implementer encounter regulatory related violations, okay, during the initial deployment. So automated compliance monitoring reduces these kind of security incidents almost by 63%. The data which is inconsistent, because there are a lot of data exchange between the multi-cloud ERP system, should be encrypted. So the TLS misconfigurations or outdated security, cheaper source, those are contributing almost 28% of this kind of integration incidents. Okay. So the organizations which are adopting layered encryption approaches experience 52% fewer data exposure incidents. The last one, data drift detection. So 24% of integration failures are attributed to undetected schema changes between these multiple cloud ERP systems. So organizations employing automated drift detection identify 83% of potential issues before it impacts the business. The proposed implementation strategy to address these multi-cloud ERP data integration issues. A phased approach to address these normalization and synchronization challenges provides the necessary structure to manage the complexity of multi-cloud ERP integration. So organizations employing structured approaches experience approximately 43% higher success rate than the organizations those attempting to concurrently implement these strategies. If you look at the strategy, the first step should be the data profiling and mapping. Comprehensive analysis on the data and its mapping is very much required. This should be the initial phase of the project. It also should understand the data quality issues, what should be addressed. Once the data profiling and mapping is done, then enterprise should move on to make sure to design the canonical model design. So spending quality time in this phase to understand the actual canonical model, which will be used by multiple cloud ERPs in the ecosystem, will benefit the enterprise in the long run. Once the canonical model design is done, now the enterprise should carefully choose the integration pattern across the cloud ERP systems. Choosing the right integration pattern will solve many of the data latency and inconsistency issues. Once organization completed this phase, we should move on to synchronization mechanism implementation. Almost 63% of the projects encounter significant technical obstacles during this phase. Incremental deployment achieves more frequent delivery milestones. Then, once all these phases are achieved, the enterprise continue to monitor and govern all these implementations and synchronization processes and frameworks. So the comprehensive monitoring reduces almost 54% of their mean time to the resolution. Effective implementations capture 25 to 40 distinct metrics per integration flow. Data profiling and mapping constitute the essential first phase in multi-cloud ERP integration, providing a very comprehensive analysis of the data structures, relationships, and business rules across the platforms. This foundation ensures the subsequent integration design decisions are based on accurate understanding of the data landscape. So there are various profiling tools available in the market which automatically analyze the sample data sets to identify the patterns, relationships, and quality characteristics that influence the integration design. Apart from doing this automated schema analysis, we should also focus on collaborative mapping. Effective profiling extends beyond simple structural analysis to include semantic evaluation, business rule and documentation, and quality assessment. In this phase, typically involves both technical specialists and also the business domain expert who provide the crucial context about the data. Quality assessment also very key in this data profiling and mapping phase. The next implementation phase is canonical model design phase. The canonical model design represents a strategic architectural decision that significantly influences long-term integration sustainability. This phase focuses on the development of intermediate data models that bridge the platform-specific schemas, providing a consistent reference point for all integration flows. If you look at it, the canonical model design phase almost reduces 37% of the maintenance cost for the integrations across the multiple cloud ERP systems. In a typical large-scale enterprise multi-cloud ERP system implementation, there will be around 120-350 different canonical definition needs to be done for various data elements which should be shared across the multiple cloud ERP system. However, considering these large-scale implementations and the effort needed to implement this canonical model design, there is almost a 25 to 30% of initial effort increase will be experienced in this implementation phase. The next and crucial phase in the implementation approach is integration pattern selection phase. Enterprise should carefully select the integration pattern for the various data elements which is shared between the multiple cloud ERP systems based on the timing constraints when the data should be available, whether it is real time or batch, based on the volume, whether it's a low volume data exchange or the high volume data exchange between the multiple cloud ERP, and what are the transformation complexity associated with these data elements. And also, if there is a data exchange failure between the cloud ERP systems, what are the recovery mechanism which is needed? All these inputs will determine the right integration pattern to be selected by the enterprise for a particular data element. In a large-scale enterprise multi-cloud ERP implementation, typically there will be 5 to 8 distinct integration patterns used for various data elements needs. What are the future directions and conclusions? So the AI-driven mapping tools which are available now in the market will use machine learning approaches to automate most complex mapping tasks and reduce the implementation time, and also improve the accuracy through pattern recognition and suggestion capabilities. Also, industry is evolving the standardized exchange format for the data elements, which will reduce all the custom transformations and mapping which is needed. The last one is the advanced conflict resolutions. The next generation conflict resolution tools using the machine learning capabilities will know the context awareness, thus provide a better reconciliation and conflict resolution mechanism. Key takeaways from this conference note: multi-cloud ERP integration requires careful orchestration of data normalization, semantic mapping, and synchronization approaches. We have seen a lot of challenges which needs to be addressed through these approaches, and also the success depends on the balancing specialized functionality with the cohesive data flow across platforms. The framework or the implementation approach we have outlined provides a structured methodology for tackling these complex challenges while maintaining the security and performance in line. So begin with the comprehensive data profiling, develop robust canonical models, and select appropriate integration patterns for each data flow scenario in a multi-cloud ERP ecosystem. Thanks everyone for spending time with me to go through this conference note.